Yeah. I was just notified that we won't be having class tomorrow, so we'll try to get as much done for the showdown today. And so I hope you guys are ready. So yeah, we're gonna be continuing where we left off on 2 days ago, and we're just gonna continue doing problems. So make sure you guys are ready and pay attention. All right.
Hello, everybody. I believe we're on number transformations. So let me share my screen. Also, I'll just quickly explain the problem. So we're given a positive integer. A position in that integer is called p, and a transition integer is called d. So the rules are as follows. If the pth digit of n from the right is from 0 to 4, add d to it. And then we replace the pth digit by the units digit of the sum. Right? Then we replace all digits to the right of the pth digit by 0. And then if it's not from 0 to 4, right? If it's from 5 to 9, instead of adding d to it, we subtract d and we replace the pth digit by the leftmost digit of the absolute value of the difference. And then we replace all digits to the right of the pth digit by 0. So if you didn't get that, you can just look at the example, right? We have this number right here, 7145032. Our p-value is 2, our d-value is 8. So that means we want to transform the second digit from the right. So if we count that, this is the first digit from the right, and then the second digit from the right is this 3 right here. And then we add our d value to it, which is 8. 3 plus 8 is 11. And we replace the 3 with 1 because we're replacing it with the units digit. Okay. Here's another example. Um, if we look at this number right here, the third digit from the right is 6, right? 1, 2, 2, 3. Absolute value of 6 minus 54 is 48. And then we replace with the 4, which is the leftmost digit of the difference. Okay, and then replace the digits to the right with zeros to get this. Oh, and the same for this one. Okay. Hopefully you got that. Let's see. That's pretty much it for the instructions. We can start coding it. Yep. So these are our constraints. N will be less than 10 to the 15. And all we're asked to do is to print the transformed number. Okay, so we have some examples here too. Um, okay, so I believe the first step is to get our input. And what I'm going to do is create input variable. So I'll just call it values. And I'll just set it equal to input.split. What input.split does is it splits the uh, string value of input into a list, right? So if we have these three numbers right here, it will split the string, this whole string into three separate strings. Okay, so we got that. So that means our n value is represented as a string, and our n value is the very first of the values, right? Because the sample input is in the order of n, p, and d. So the very first value is n. The second value and third value are p and d. So I'll just do right. This is our p and d values. This is our n value. Okay, so we have all our values. Yeah, let's see, let's read the rules. So we have to first, let's actually create a variable. I'll call it pth, right? The pth uh, digit. And what we're going to do is we're going to set it equal to int, then the pth value, and then ln minus p. Right, so this is the pth digit, right? And if I kind of explain this, um, the when you count from the right and you make your way towards the left, this right here has an index of length -1. This has an index of length -2. So that's why I wrote ln n minus p. And then I casted it as an integer. And let's actually also create a value called results. And we'll set it as an empty string because our goal is to add to the results. Uh, Actually, what we can do is we can from to len and this p. This right here retrieves the first part of our results. It's retrieving everything before the pth digit. Since all we're doing is transforming the pth digit and everything to the right of it, we could create initialize our result variable as the first part of our result. So let's create some if statements. So if our pth digit is less than or equal to 4, all right, so that's the case, the very first case right over here. We add d to it. So what we'll do is we'll just add d to it. And since this is a string right here, we want to typecast it as a string. Then add d plus d. And then replace the pth digit by the units digit of the sum. All right, so if this is the sum, then the units digit we get by using the modulus. Right. And then everything after it to the right we replace with 0. So what I'll do is just create a 0 string and then multiply it um, by p, right? Or sorry, p minus 1. Yeah, p minus 1. So that way you're replacing all the numbers after the p digit with 0, like so. And then otherwise, um, the other one is subtract d from it. We replace the absolute, okay, the leftmost digit of the absolute value of the difference. So right here, choose that. And the absolute value of the difference is p minus d. And then, since this is a string, we can just get the very leftmost digit. And then same here, we want to replace everything to the right of it with zeros. So we'll do the same thing. And then all we have to do is print the result as an integer. Okay. So let's just run the code and see if it works. Okay, yeah, it worked. Let me try submitting the code. All right. Okay, so this is my code. If you still need to, if you still need me to explain, I could explain it right now. But I'll leave my screen like this so you can copy it. Yeah. I'll just explain what I did. So I think you get this part, right? Um, these are our values, our three values. Actually, let me copy this. Okay. This we split um our input as a list. So we basically turned this string, right, from our input function, we turned that into a list. So this right here, values, is a list of three strings, this string, and this string. And those strings are our N, T, and D, right? So the first uh, string is N, the second string is 3, or in this case, it's 3, but this the second string is P, and the third string is D. Okay. And then right here, I turned P and D into integers. So I kept N as a string because it's much easier to perform uh, like string manipulation. So I kept N as a string, and P and D are integers. Okay. And PTH right here, or Pth, is our Pth digit. And what that means is, let's say, for example, you have your p value equal to 3, then that means you perform the transformation on the third digit from the right, right? So the third digit from the right means you count from the very right of the string and you make your way towards the left. So this right here, for example, 0 is the first digit, 5 is the second digit, 9 is the third digit. So this right here, I created an integer variable, and then this right here means pth digit from the right. And the logic behind that is you can represent an index to the very right of, or you can represent the very last uh, character as len of n minus 1. And then if you want to get the second to last character, you do len of n minus 2. and then so on and so forth. So that's why I did len of n minus p, right? Then right here, I retrieve the first part of our result because all we're doing is forming the transformation on the pth digit, right? So if the pth digit is 6 right here, then 5, 4, and 0 are already determined and they don't get changed, right? So that's the very first part of our result. Okay, and this right here, I uh, did an if else statement, and I basically followed these rules, right? So if it's less than or equal to 4, or uh, if the pth digit is between 0 to 4, otherwise if it's between 5 to 9, right? So if it's between 0 to 4, all you have to do is add your d value to the pth digit, then find the units digit, which is the ones place, right? So I did mod 10, and then anything to the right of it, I just put zeros, and then I multiplied it by p minus 1 because that's how many zeros are needed to replace all the digits to the right. And then for this one, I followed the rule. If it's between 5 to 9, I took the absolute value of the difference. I turned that into a string, and then I took the very first digit, right? Because it says replace the pth digit by the leftmost digit. Okay, so I turned it into a string and took the very first character. And then the same thing, I put extra zeros uh, to the right of the pth digit. Yeah, hopefully you got that. Uh, any other questions? I'll post this on the live lecture notes so you uh, can review this in your own time too. Okay. Yeah, I believe that's it. I guess I'll pass it off to the next teacher.
Hi everyone, I'll be going over the next two problems. So the next problem is called Fibonacci. But okay, sorry about that. Okay, so here's the problem. So I'm gonna read the problem and then I'm gonna try to explain the problem to you guys and then show you guys how to solve it. So the Fibonacci sequence is attributed to Italian mathematician Leonardo of Pisa. It is represented as a sequence of integers starting with 0, 1, every number after the first two, is the sum of the two preceding numbers. The beginning of the Fibonacci sequence looks like 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. The task is to write a program which renders the nth number of the Fibonacci sequence. For example, if given an n value of 9, you are to return the ninth value of the sequence, which would be the number 21. Input format. The following, or the first line of the file will contain a positive integer t, denoting the number of test cases that follow. Each test case will have the following input: a single positive integer, which represents the position in the sequence for which you are to determine the value. The number will be less than or equal to 90. For each test case, your program should outline or should output one line containing the sequence position and the value of the integer at that position in the Fibonacci sequence. Each line of output should be in the format position equals value. So here they give us a sample input and output. So the first number here represents the number of test cases, which is 7. And for the output, you just have to do the input, and then after that equals, and then whatever the number is in the sequence. Okay, so I'm gonna go ahead and start to code the solution. So to approach this problem, I first have to go over something. So let's see, where do I start? So basically, one way to approach this problem is to, for every time you try to calculate the number for a sequence, you add all the numbers up to that position for each time you do it. And obviously that would take a long time. But another way you can do this is to just create like a list, for example, and then just calculate all the numbers once, and then refer to the positions so that you don't have to calculate the same things over and over again. And the second method is a lot faster because when n starts to increase, the time it takes and the repetition that you do increases as well. So to try and minimize that, we're going to try to implement the second method that I talked about just now. So first, we're going to make a variable called sequence, and it's going to be a list. And the list is going to contain 0 and 1, which are the first two values of the Fibonacci sequence. And then after that, so we're given in the input format that the number will always be less than or equal to 90. So what that tells us is for I in range, that means that we only have to calculate up to the 90th position for the sequence. So that's what we're going to do. And that's why we do range of 2 to 91, because we already have first two values. So the index would be 2 starting from the next one. And we end with 90, right? So that's that. And then for each iteration, we're just going to use the append method to add the sum of the two the two numbers that are at the very end of the list. So we're going to do sequence I minus 1 plus sequence I minus 2. And what that's going to do is it's going to create the Fibonacci sequence in the list up to 90 values. So after we do that, we're going to take in n for our input. We're going to make sure to cast it into an integer. And then we do for I in range n because there are n input numbers that we have to calculate. We're just going to do, we're going to store the input inside a variable called var. We're going to cast it into an integer because we need it as an integer. And then we're going to print string. So we're going to print the variable, but we first have to cast it into a string before we concatenate it with other strings. And then we're going to use the format that they give us at the top. And then we use var -1 to refer to the list that we just created and then get the number that corresponds to the number in var. And then we cast it into a string, and then we concatenate all of this, and then we should get the answer. So we passed the sample test case. And we also passed the other test case. So does anyone have any questions for this one? Okay, well, I'll leave this up for like 1 more minute, and then I'm going to move on to the next problem, just so that you guys can copy it down or ask some questions. Yeah, sure. So I think you are referring to this line. So basically what this line does is for each iteration of the for loop, we're going to add the sum of this, of the two preceding terms. So if I were to demonstrate what the actual code was doing, oh, right, I have to. Okay, so if I were to demonstrate what the code was doing, then so the first two values are 0 and 1, right? But if we were to execute this code, what it would do is it would take the sum of 0 and 1, which is just 1, and then it would append it to the end of the list. So it would add 1. And then next, it's going to add the two terms again, the two preceding terms. That would be 1 and 1. And then it would add it again to the end of the list, and that's 2. And it keeps on doing that. So 1, 2 would be 3, 2, 3, 5, 3, 5, 8, 5, 8, 13, and then so on. So we're basically recreating the Fibonacci sequence that they give us right here using code. So that's what that line is doing. Does that make sense? Okay, nice. So I'm going to move on to the next problem then. The next problem is called Change for the World. So just like last time, I'm going to read the problem and then I'm going to show you guys the solution. So some people really like coins. You happen to be one of those people. In a world filled with electronic payments and banking from your cell phone, you prefer to deal exclusively in cash, specifically coins that are generally available, no silver dollars or half dollars for you. However, you are also practical. I mean, paying for your lunch in pennies? That's just silly. In order to strike the right balance of quirky and practical, you need to be able to pay for things using the fewest number of coins possible, and your program will help you do just that. Input format. The first line of the file will contain a positive integer t denoting the number of test cases that follow. Each test case will have the following input: a single line denoting the dollar amount to be converted. Output format. For each dollar amount given, have your program calculate the fewest number of coins necessary to arrive at the dollar amount. Your program will output the following. The first line should contain the dollar amount exactly as it appears in the input. The next line should contain the amount of quarters in the following format. Quarters equals amount of quarters calculated. The next line should contain the amount of dimes in the following format. Dimes equals amount of dimes calculated. The next line should contain the amount of nickels in the following format. Nickels equals amount of nickels calculated. The next line should contain the amount of pennies in the following format. Pennies equals amount of pennies calculated. Note, if a coin was not used, still contain that coin in the output with a zero amount. So for example, pennies equals 0. Okay, and basically they give us a sample input here. I'm just going to go over one of them to give you guys a feel of how this is going to work. So obviously the first number represents the number of test cases that they're going to give us, and that's 4 here. So for the first test case, we have $3.87. And to minimize the number of coins that we're going to use to get this value, we first want to use as many quarters as we can until we can't. So in this case, the most number of quarters that we can use is 15. Next, the coin with the most value is a dime, which is worth 10 cents. After we use the quarters up, we're going to try to use the most amount of dimes as possible. And hint, dime can either be 0, 1, or 2 because quarters is worth 25. But anyways, after that, we have nickels, which is worth 5 cents. And we're going to use the most number of nickels that we can. So that would be 0 or 1. And after that, the coin with the least worth or value is a penny, which is worth 1 cent. And after we use the most amount of coins for all of these, we're going to use the remaining amount that's left using pennies. And that would be either 0, 1, 2, 3, or 4. So using that strategy that we just kind of used in our head intuitively, we're going to try to code that exact solution. So first, we're going to get the number of test cases and then store it in the variable n. After that, we're going to use a for loop to go through the n test cases. And for each iteration of the for loop, for each test case, we're going to first get the string or the input So that would store this. And the reason why we do that is because when we're printing the output later on, we first need to print the value first, and then we need to print our answers. So we need to store that in some sort of variable. So we store that in the variable called string. After that, we're going to get, so let me just write this out. We're going to store the amount of cents that this value has by using this following line. And what this basically does is, so we basically have this string, right? But in Python, if you were to try and turn this whole thing into a float, it wouldn't let you do it because of the $sign. So what you can do is you can use the fact that you can refer to each character of the string using indexes to basically cut the $sign off, take the rest of the number, which is a float, and then cast it into a float. And then we multiply it by 100 because there are 100 cents in $1. So for example, what this would do for this test case is it would give us the number 387. For this one, it would give the number 274. And for this number, it would give us 1,484. So that's what we're basically doing. After that, we're going to calculate the number of quarters. And as I explained earlier, we're going to do that by calculating the most number of quarters that we can fit inside the amount. And the way we would do that is using floor division and dividing it by the value of a quarter, which is 25. And what that's going to give us is, so if we divide amount by 25, and we're going to get, or floor divide by 25, then we're going to get the most number of quarters that we can fit in that amount. And that would be our answer for quarters. And then we need to update the amount variable. And we're going to use that by doing mod 25. After that, so now we've updated, since we've updated our amount, now we can try to calculate the number of dimes that we use. And we do the exact same thing. So we divide amount by 10, or floor divide by 10 to get the number of dimes. And then again, we update the amount variable by doing mod 10. After we update the amount variable, we do the same exact thing for nickels. So amount floor division 5. And then update the amount variable. And then we do pennies. So for pennies, we don't have to divide anything because the amount that's left is going to be the number of pennies that we use. So we just do pennies equals amount. And then what we can do to print the output is recall that we need to print this string before we print all of this. So we're going to print string first, and then we can go ahead and then print quarters equals and then do this with the other ones. So dimes, nickels, and pennies. And the reason why we have to cast it into an integer first is because If you recall, we our amount variable is actually a float. So what that's going to do is it's going to turn all of these numbers into floats as well. So even though we get whole numbers, we're going to get things like 4.0 or like 5.0 or 2.0. And that's actually not what we want in our answer. We just want whole numbers. So that's why we first cast it into an integer. And then, of course, in order to concatenate it with the first string, we then have to cast it into a string and then print it. So that should give us the answer. Did I do something wrong? Sorry, I'll get to your question before or after I do this. Um, actually don't know why it's not working. I'll try to run it again. Hmm. Yeah. Um, Not sure why it's not working, because it was working before. Okay, sorry guys, I'll try to figure the problem out. But in the meantime, next person can take the next problem. So yeah, I'll pass it on to the next person.
So let's see. Going over I'm bored, and actually I think we might have went over this one last time. Could you guys tell me if you've seen this one before with the squares? Because last time I accidentally explained one of the wrong programs, and I think I might have explained this one before I was supposed to. So can someone tell me in the question and answer chat if they've already seen this one, or if they want me to explain it again, I can explain it again. Okay, I'll just go over this one anyways, just as a refresher, I guess. So I'm bored. It's a problem where we get n test cases. So in this case, it'd be 2 test cases. And we want to make basically a board that is a square board that is a certain number of hashtag symbols wide and a certain number of hashtag symbols long. And for each test case, we need to make its own separate square. So in this case, it is 2, 5, and 3. So we want to make one that's 5 wide and 5 long, and we want to make one that's 3 wide and 3 long. So the way we would do this is we would first read the number of test cases. So n equals int input. Then iterate through each of the test cases. So, oh, the indentation's being a little weird. Okay, that's better. So for I in range n, a equals int input. So we're reading each case. And then we'd have nested for loops to create the square shape. So for j in range a. So this for loop is iterating through each of the rows. So in each iteration of the for loop, we need to make a single row. So what we're going to do here is have a string s equals just an empty string. And then we're going to iterate through for k in range a again. Then have this statement s plus equals £, space, and then print s. So basically, this would make each row. So each S would basically just be pound sign space, pound sign space, pound sign space. And then for the size of the square, it would repeat this. So it would make 5 rows of 5 long, respectively. And so if I run this, get the correct answer. If I submit this, it's correct. So I'll leave this up for a second. And again, if you have any questions, let me know. If not, then I'll have to pass it back to Taeyeon, who I believe is going over the next question.
Yeah. Hi again. I'm going to go over a problem called anagram checker. I'm going to read the problem and then I'm going to go over the solution. So, an anagram is a type of wordplay, the result of rearranging the letters of a word or phrase to produce a new word or phrase using all the original letters exactly once. For example, the word stop can be rearranged into the word tops and pots. An individual who creates anagrams is called an anagrammatist. You've been hired by Anagrammy to create an anagram checker program that they can use to determine whether words submitted by their users are anagrams or not for the purposes of determining a monthly contest winner. Anagrammy only wants to check word anagrams in their anagram checker and not deal with phrases for their first release. Anagrammy needs your help in order to officially release their website. Input format. The first line of the file will contain a positive integer n, denoting the number of test cases that follow. Each test case will have the following input: a single line in the format first word, separated by a vertical line, and then second word. Note, words will be made up of capital letters A to Z only. There will be no special characters and no lowercase letters. Output format. For each test case, your program should output one line. If the two words are anagrams, you will print first word, vertical line, second word equals anagram. If the two words are not anagrams, you will print first word, vertical line, second word equals not an anagram. Not an anagram. And we have a sample input and output here. So most of these cases are pretty self-explanatory. But there is one case, and it's the last one that you have to be careful of, which is the fact that if the two words that you're comparing are the same exact words, then you have to say that they're not an anagram. So that's one case that you have to be careful of. But other than that, yeah, it's pretty simple. So I'm going to code the answer to this problem. So what we want to do first is get the number of test cases and then store it in the variable n. Then we're going to iterate through a for loop n times in order to solve for the n test cases. And for each test case, similar to the problem like change for the world that I previously did, we're going to store the whole line of input inside the variable called line. And the reason why we do this is because it just makes it easier later when we're printing the output, because we need to reprint the input and then write equals anagram or not an anagram. So we're going to store it in a variable called line. And then we're going to create two variables, first word and second word, and then we can do this. So what this is basically doing is, so we have our input in line, right? And we know that the two words are separated by the vertical line, right? So we can split the line using the split method by its vertical line. So now the words will be separated into two strings, right? And then we can use this syntax that we went over a while back in order to set the first element of this list for the first word, and then the second word for the second element. So now we have our first word in the variable first word and the second word in the variable second word. Now we do if. So earlier I talked about the case where if two words are exactly the same, then we write that it's not an anagram. So what we're going to do is if we're just going to take care of this test case first. So if the first word is equal to the second word, then we're going to print the line, right, which is the input, and then equals not an anagram. Okay? So after we take care of that case, that special test case, we're going to do else, and then we're going to sort. Actually, sorry. First, we need to make the strings into lists. And the reason why we need to do that is because right after this, we're going to sort the letters. And in order to do that, we need to turn the words or the strings into list so that we can sort the characters. So yeah, we store the list of characters in the variables first chars and second chars. And then right after, we just sort the elements of the lists. And what's going to happen is we're going to rearrange the letters of the string in alphabetical order. So, for example, let's say we were doing this test case, right? What would happen is if we sort this word, we're going to get OPST, right? And if we also sort this word, then we're also going to get OPST. And in that case, if the sorted lists are the same, then we're going to know that the two words are in fact anagrams. However, if the sorted lists are different, then in that case, we know that the two words are not anagrams, because we know that in order for the two words to be anagrams, they need to consist of the exact same number of letters, right? So that's kind of what we're doing here. So we just do if first chars equals second chars, and we're going to say that this is an anagram. And of course, else, if the characters or the lists are not the same, then we're going to say that it's not an anagram. And that should be it. So I'm going to run the code. Okay, so we pass the sample test case. And we also passed the other test case. So I'm going to leave this code up for one more minute. wait for any questions that you guys might have. You guys can also take this time to write the code down, copy it down. So if you guys have any questions, you guys can feel free to ask them in the question and answer channel. So it's been 1 minute. I don't see any questions in the channel, so I'm gonna go ahead and pass it on to the next teacher for the next problem.
Okay, so I'm going to be going over post office. So basically, in this problem, we're given the length, the width, and the thickness of basically an item that the post office gets. And so we have to classify it into these 7 categories. So in a regular postcard, the length needs to be between 3.5 and 4.25 inches inclusive. The height needs to be between 3.5 and 6 inches inclusive, and the thickness must be between 0.007 and 0.016 inches also inclusive. So that's for regular postcards. For large postcards, the length must be between 4.25 and 6 inches. The height must be between 6 and 11.5 inches, and the thickness must be between 0.007 and 0.016 inches inclusive. For envelopes, the length must be between 3.5 and 6.125 inches inclusive. The height must be between 5 and 11.5 inches inclusive, and the thickness must be between 0.016 and 0.25 inches. For large envelopes, the length must be between 6.125 inches and 24 inches. The height must be between 11 and 18 inches inclusive. The thickness must be between 0.25 and 0.5 inches inclusive. And package is when the item exceeds all the rules for the large envelope, and when the length plus the distance around the other sides of a package equals 84 inches or less. So let me try and visualize this a bit. Let me change what I'm showing. Okay, so when it says here the length plus the distance around the other sides of the package, it means basically, let's think of each package as like a kind of rectangular prism. So here's kind of a crude sketch of a rectangular prism. So we have the length of the package, so we say this is L length, and then we want to find the distance around the other sides of the package. So basically the way we get that is want the distance, we have the height here, then we have the thickness here, which I'll just have as T. So basically the way we do this is we want to get the surface area of this, and then we can't see this here, but let me just, this side, and we also want the surface area of this side, I believe. So we would get that the way we would get the surface area of, actually wait, yeah. Actually wait, 1 second, I think I might have gotten something wrong here. Want the distance around the other sides of the package. So this is kind of unclear of what it means. But basically, you have length this plus distance around. You could say it's the distance like. I kind of thought of it like the surface area of this side, but yeah, it's kind of confusing, but so anyways, and this sum has to be 84 inches or less for it to be a package, and for it to be a large package we need to have this sum more than 84 inches, but also less than 130 inches. And unmailable items do not meet any of the requirements. So, when we solve this, first thing we do is, of course, read the input for I in range 5. Since in the problem it says there will be 5 input lines, or at least up to 5 input lines. So we'll try to read the input, and if there is no input, we'll just accept it. So A equals input dot split. So basically I'm taking all of these and splitting them up into individual numbers without the spaces. And if it doesn't find an input, it'll just break out of the code. So length equals float, because these are numbers with decimals, so we need to cast it into a float. A is 0, height equals float A of 1, thickness equals float A of 2. So the first thing we need to check for is a regular postcard. And in regular postcards, length is between 3.5 inclusive and 4.25. And the height is between 3.5 inclusive and the thickness is between 0.007. Thickness inclusive. And else if these are the parameters for a large postcard. Actually, let me see. Okay, so in a large postcard, these dimensions are not inclusive, these first two, so I wouldn't have the equal sign. It would just be 4.25, 6, and 6 less than height less than 5, and 0.07 less than equals to. Since the thickness is inclusive, 16 print large postcard. And then we have envelopes, which might need to be between 3.5 inclusive 6.125. Same with the height, 5, but it's 5 and 11.5. The thickness has to be between 0.016 and 0.25. Then this one's for large envelopes. Length is between 6.125. Let me just check if this is inclusive. This is not inclusive. Length is not inclusive, so we don't need an equal sign, but the height and the thickness are. That's the maximum length. The height needs to be between 11 and 18. Thickness is between 0.25 and 0.5. This is for large envelope. And for the package, you need to add the length plus the length plus the distance around the other sides. So I guess we could try different interpretations of this. Length plus the distance around the other sides could just mean length plus height plus thickness. So we could try that. But we see in one of the test cases, we have 10, length of 10, height of 12, and a thickness of 30. This is a large package, which means that the sum we're looking for has to be over 81 inches. So if I open up my calculator, 10 plus 12 plus 30 is less than 84, so we have to multiply things somewhere. So, we could interpret this as the whole surface area of the package, but I think that's too big, because that would be the length times 4, be the height times 4, and then the width, the thickness times 4. If we times everything by 4 here, 52 times 4 would be 208, which is bigger than a large package since it needs to be 130 inches. So I think the solution I went with was taking the length first, and then we add what's basically the surface area of one of these sides. So we have the height plus thickness times 2. So if length plus 2 times height plus thickness is less than 84, print package. Then for the case of the large package, it'd be length plus 2 times height plus thickness. Then it's less than 130, less than or equal to actually. And then we print large package. And otherwise, if it doesn't meet any of these requirements, then we would print unmail. If I test this code, oh. Let's see. .18. So let me go through this. So this needs to be a package. It's to be 7. The thickness needs to be 0.25 and 5 for it to be okay. This says I'm saying it's a package even though it's supposed to be unmailable. Okay, so the length is too big to be a large, length is too small since the length is, actually length is 7. Okay, so length fits into the large envelope's bounds, 6.15 and 24, but the height doesn't fit into 11 and 18 inches, so this wouldn't be a large envelope. And if we read closely here, I think actually the item exceeds all the rules for the large envelope. So the length needs to be bigger than 24. The height needs to be, actually I don't think bigger, but basically if the height was like say 20 inches, then it would be bigger than the large envelope's maximum height, which means it could be classified as a package. But right now the height is too small for that to happen, so we need to add something to check that case. So this, then I would change it to length is greater than or equal to 24, or height is greater than 18, or thickness. Thickness greater than 0.5. Okay, so let's try this case. Then if elif, we would just move this up here, and then add another else. If this doesn't fit any of these requirements, then we also have to print unmail. And it looks like I forgot some parentheses here too. Okay, and now it passes these test cases, so let me try submitting this. And it passes everything. So I'm just going to leave this code up for a second. And if there's any questions, just let me know. If there's no questions, I can go over the next question. Well, next problem. That's probably a better way of putting it. So this one's called wraparound code, and this one also has kind of a lot of stuff going on. So basically in this code, in this problem, we get a letter as our input, and basically we need to convert this using the numerical value of each letter, which means this is 1 based, so A is 1, it starts from 1, A is 1, B is 2, etc. And so here we get some rules here. So if the letter's between A and E, then we have to multiply its value by 2. if the letter is between F and J, we have to multiply its value by 3, then we divide it by 3, and then we have to take the remainder and we have to multiply by 5. If it's between K and O, then we have to divide it by 4 and then multiply the integer part of the quotient by 8. So we need to do integer division here. And if it's between P and T, then we have to multiply the sum of the digits of its numerical value by 10. So, and if it's between U and Z, then we have to find the largest factor of its numerical value, less than the value itself, then we have to multiply it by 12. So, let me just bring out a letter to number chart. That'll make things a bit more clear. So, let's see. It's the wrong tab. Okay. So, let's just think about some examples. Let's say we have B. So B is 2. So if we multiply its numerical value by 2, then we get D. And you can see it's B and D. Let's see, we have G here. A, B, C, D, E, F, G. So with G, we have to multiply its numerical value by 3. Then we take the remainder and multiply it by 5. So we bring out our trusty calculator again. G is letter 7 here. And then we divide it by 3, so I'll do 7 modulus 3, then we get an answer of 1. And then we multiply this by 5, so we get 5, which is E, so G turns into E. And lastly, we have Z as a sample case, so that's 26. And the biggest factor of 26 is 13, because if you divide by 13, you get 2. So we take this, take 13 and multiply it by 12. And if we do this modulus 26, we'll get 0. And that just means it is 26. But this is a case we'll have to deal with later because it's kind of weird. I'll explain it later because you see here, it actually says if a numerical value of 0 is evaluated, print a hashtag symbol. And we see that Z actually turns into Z because even though it's 0. So we'll have to deal with this specific case because sometimes we'll get 0 and get a pound sign, but sometimes we're supposed to get Z, but we'll actually get 0. So this is because the way the modulus function works. So if we think about this, right now, if we did mod 26, we're treating this like it's a list, except A starts at 0. So if A started at 0 and Z was 20, if Z was 25, then it would make sense because 0 would wrap around all the way to, well, basically, okay, that explanation was kind of not really helpful to this, but basically the way we should handle this is we should take 156, then we should subtract 1. So basically what this will do is bring us to 155, and if we do modulus 26 on it, we'll get 25, and if we add 1 after that, we get 26, which is our correct answer. And this just happens because 26 modulus 26 is 0, so it sets 26 to 0 when it shouldn't be sometimes. And if we get the value of 0, then there's another way we can check for that and deal with it. So in this code, let's start with reading the input, so A equals input. And so I'm just going to have another variable B, but B basically means the number version of A, so we'll take ORD A, which converts it into its ASCII code, which is basically like a thing where we have letters mapped to numbers, and then we have to subtract this from A and +1. And basically what this code does, it just prints out, well, I can make it print out the number value of each letter, so I'm just going to run this right now. And this doesn't work, but as you can see, what it does is it makes B equal to 2, it makes G equal to 7, and it makes Z equal to 26. That's what we really need right now. And so, using our trusty letter number conversion table, we can start thinking about all of our different cases. So if B is greater than or equal to 21, which would be U, we would have to make B equal to fact. So we have to find the biggest factor out of B and then times it by 12. So I just made a helper function to make this more simple. Define fact num. So we're finding the biggest factor out of here. So for I in range num minus 1, 1 minus 1. So basically what this does is it basically starts from, let's say we're trying to find the biggest factor out of 22. It'll start from 21 and it'll check, is 22 divisible by 21? It's not, so we go down another one, and then it goes down, and it basically reverse for loops until it finds something that you can divide 22 by. So we'd have a code if num divided by I equals num integer divided by I. So it's basically checking, is there a remainder here? This actually, there's another way we could do this. It's just if num percent I equals 0. This is probably a more clear way of doing this. It's basically if there's no remainder, then we return the number, basically the first factor we find. And in the case it doesn't find a factor, we're actually just going to return error. And this will cause an exception in the code, so we know that something went wrong. Because the way this code works, it should find a factor no matter what, since it goes from, let's say 22, it goes down each of the numbers and checks. So it'll even check 1, and if we find that a number can't be divisible by 1, then I think there's a problem in our code, right? Because everything's, well, pretty much everything's divisible by 1. So we'll check for our next case, which is when B is greater than or equal to 16, which is the number of P. So I'm just going to make a temp value. So I'm going to convert our number into a string. And this will become helpful in a second, because in this case we want to take the sum of each individual digit. So if it was P, then we would take 1 plus 6 equals 7. So converting it to a string just makes things more convenient. And I'll just have a count equals 0. Then for I in a temp, count plus equals int I. So this basically gets every single individual character inside the string, which is just up to 2 numbers. So we would just add them together and get the sum of all the digits. And then we make B equal to count times 10, because we want to multiply the sum of the digits times 10. So the case where B is greater than or equal to 11, so this is K, we want to divide it by 4 and then multiply the integer part by A. So what we would do is have B equals B integer divided by 4, so it would remove whatever decimal that's attached to this, and then we would do B times equals 8. This one is pretty simple. And then else if B is greater than or equal to 6, in this case that'd be F, and in the F case we want to divide it by 3, then we want to get the remainder and multiply it by 5. So we could just, since there's the percent sign operator, we can just directly get the remainder. So it would be B percent 3 times 5. In the last case, we just need to multiply the value by 2. B times equals 2. And then the last thing we need to do is we need to make sure B is a letter, because B can sometimes be a crazy big number like we had here with like a 150 something. So what we need to do is cover the extra case we talked about. So B equals B minus 1% 26, and then B plus equals 1. We'll also have another check value, check equals B. And this is just to make sure whether B is 0 or not, because if B is equal to 0, then we need to print out the hashtag sign. So do if B equals 0 or temp equals 0, then we'll print hashtag else. And this is the normal case, so B equals B plus word A minus 1. And basically what this code does is it basically puts B back into the character format that Python has it in at first. So you saw how we converted the letter into the number by doing ord A minus ord capital A plus 1. We're basically just doing the opposite here. We're adding ord A and subtracting 1. So this basically brings it back to, if we do print character B, then this will basically convert it back into the letter it used to be, back from the number. So if we run this code, oh, sorry, wrote the wrong variable, check. And you see it passes all the test cases. If I submit this, there's something wrong here. Let me double check for any errors in this code. Let me just let me get my code that I used originally here and just check it. Okay, that's weird. The code I wrote before works, but this one doesn't, so I might have made a small mistake somewhere. Okay, for the sake of time, I'm just gonna copy paste back in my, actually I'll just show you guys the code that I used myself. So you can see that this code passed all the test cases, and it's pretty much the same thing as what I showed you guys, except some of the variable names are different. I just changed them when I was explaining this because some of these are a little confusing, like A, B, C, D, that kind of thing. So I'll just leave this open for you guys to see, and if there's any questions, of course, let me know. If there's no questions, then I'll then we'll go back to a new speaker, actually. And I believe it's Baron's turn now.
I'm gonna go ahead and share my screen now. So in this problem, it first introduces something called the triangle inequality theorem. That might sound a little confusing, but here it is. So it just says that the sum of the lengths of two any sides in a triangle is greater than the length of the third side. So you might be a little confused as to what that means exactly, but all it means is that when you have a triangle and you add two side lengths, it always has to be greater than the third side length. Okay, so we'll see some examples of that in a bit. But so it says that sounds easy enough, right? And then your job is to write a program that can identify valid triangles. And not only do you need to determine if the three sides can form a triangle, you also have to tell what type it is, right? And so there are three classifications of triangles. Equilateral triangles have three sides of equal length, and isosceles triangles have two sides of equal length and one that is different. And scalene triangles have no equal side lengths. Okay. And so equilateral triangles, all three sides are the same length. And then for the isosceles triangle, it's going to be two equal sides and one side that is different. And then for the scalene triangle, all sides are going to be unique. So the first line of the input will contain a positive integer t, denoting the number of test cases that follow. And each test case will have the following input: a single line with three side lengths separated by space. Okay, so first we have t, and t says that we have four test cases here. And then each test case will have the following input, and it's just a single line with three side lengths separated by a space. So these are the side lengths of one triangle, right? And there are multiple triangles that we want to look at and see if they're triangles and determine what type there are. And so for the output, we have to output one of the four possibilities. So the first one is not a triangle. The second one is equilateral. Third one is isosceles. And the fourth is scalene. So we just went over the types of triangles, and all we need to do is just print out which type of triangle is, here. So which one is given. So let's look at the first, let's actually go through the sample input and output together. So the first one, right, we have 20, 20, and 3. And so if we look at the definitions of the triangles, isosceles triangles have two sides of equal length and one side that is different. So this seems to fit that, right? Two side lengths that are equal and one that is different. So it is an isosceles triangle here. The next type of triangle that we see is the equilateral, and we know that it's the equilateral because all three sides are the same. And next we have another triangle, and here we see that all three side lengths are different. So we know that it's going to be a scalene triangle because scalene triangles have no equal side lengths. Okay. And then finally,
if we look here, this is not a triangle. And that's because the first side length plus the second side length is actually less than the third side length. And so obviously the rule of the triangle inequality theorem states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. And since 13 plus 14 is 27 and 27 is less than 30, this is not a triangle, okay? So that's the sample input and output. Now let's begin coding. And we can first begin by taking in the input. Through each of the triangles, right? And we're trying to take in the side lengths one by one. So let's do this first. We're gonna name them. We're gonna name the side lengths each, and we're just gonna keep it simple. We're gonna name them 1, 2, and 3. And then we're gonna set them equal to, I'm gonna write out the code and then I'll explain what it does. It's just easier that way. So what this does is, first, we have 3 variables, 1, 2, and 3, right? And then we have the input function, right? And then so that takes in the entire line. And then we run this split function on our input. And what that'll do is it'll separate it by each line, or sorry, by spaces. And so 1 is going to be equal to 20, 2 would be equal to 20, and 3 would be equal to 23. However, we want to be able to work with them as numbers, right? That's how we're going to do the comparing and all of that later on. So because of that, we need to use the map function to make each of them an int. And remember that the map function takes in another function and then an iterable. So an iterable is something that you can just go through, right? Like, for example, here, this has multiple things, right? And you can go through them one by one. That's an iterable, okay? So we're going to go through each of the things in the iterable one by one, and we're going to run the function for each of those elements in the iterable. That's what the map function does. So it's just making all of these, which were originally strings, we're going to make them into integers, right? We're casting them basically. And so the next thing that we have to do is we have to start seeing, or we have to start checking what kind of triangle we're dealing with, okay? So the first thing we're going to check is if it's not a triangle. So remember, because that's the hardest one, so let's just get that out of the way, right? So if 1 plus 2 is less than 3, or 2 plus 3 is less than 1, or if 1 plus 3 is less than 2, then immediately it's not a triangle, okay? And so, actually, my apologies. It's less than or equal to. So if 1 plus 2 is less than or equal to 3, even if 1 plus 2 equals 3, it's still not a triangle. So we're just going to put that in our if statement here. So if 1 plus 2 is less than or equal to 3, right? That's one of the cases, right? If two side lengths added together is less than or equal to the third side length. That's one of the cases, right? So let's do the two other ones. So the second one would be or 2 plus 3 is less than or equal to 1, right? And then the last one is or 1 plus 3 is less than or equal to 2, okay? So these are the three test cases to see if it's not or these are the three conditions that it shouldn't meet if it's a triangle, right? If it isn't a triangle, then it's gonna one of these is going to be true, okay? And we're gonna say if one of these is true, right? That's why we use or. So if one of these is true, we're gonna print not a triangle. And triangle here is capitalized for some reason, so we're going to follow that so that we get the answer correct. And then next we're going to do an else if, right? Else if. Else if, let's do an easy one. So if, actually, I need to remove these parentheses, but let's say if 1 is equal to 2 and 2 is also equal to 3, right? Then we're going to print equilateral. Because remember, an equilateral triangle is characterized by having 3 equal sides. So an equilateral triangle just has 3 sides that have the same length. And then finally, or actually not finally, we have 2 more to go. But the second to last one, and this is going to be the last thing we cover today because we're out of time. But if 1 equals 2 and 2 is not equal to 3, right? We're doing the isosceles triangle right now, right? And the isosceles triangle has 2 sides that are equal and 1 side that is not. So similarly, like the not a triangle case, we have to do every single possible combination. So it would be like if 1 and 2 are equal, but 3 is different. And then if 2 and 3 are equal and 1 is different, or if 1 and 3 are equal and 2 is different, right? So we're going to do each one of those, right? So if 1 equals 2 and 2 is not equal to 3, or if 1 equals 3 and 2 is not equal to 3, or 1 equals 3 and 2 is not equal to 3, or if, let's see, if 2 is equal to 3 and 1 is not equal to 2, right? So all of these characterize a isosceles triangle because all of these, they just check if 2 sides are equal and 1 side is not. And it just does that for every single combination possible. There's not that many because it's a triangle, obviously. So we can just brute force it like we are doing here. And so, give me 1 second. Okay. And so if this is the case, then it's going to be isosceles. And then isosceles is spelled isosceles. And that's all we have time for today. But we will continue this problem the next time we meet. And so I'm going to give it back to the host.
All right, guys. Thank you so much for another day. Tomorrow we won't have any class due to it being a holiday, so we will see everyone next week. So until then, please be safe, and we'll see you then. Bye.